Welcome back to the start of Unit 8, Graphing Functions. All right, for this entire unit, you're going to have to make sure that you always have your graphing calculator handy as well as a writing utensil. All right, today we are going to start with video 0. So we are starting with 0 because today is not going to be so much new learning as it is going to be a little bit of review of some background knowledge that we're going to need. So our goal for the video, to review function vocabulary and writing equations of functions. All right, so let's jump right into it. So our first three vocabulary terms, we have our function, domain, and range. So as a reminder, your function is a relation for which for every value of the domain, there is one and only one value of the range. So in other words, no x values will repeat. Or if you're looking at a picture, it's going to pass the vertical line test. Okay, your domain is the independent values. Okay, so that's a vocabulary word there. They are your independent values, okay, of the relation or function. In other words, they are your x values. And the range is your dependent values, which are your y values. All right, so let's go ahead and let's take a look at two examples. So in our first example, we see that we have a graph with a bunch of different points. And if you take a look there, your points are all listed to the side. So the first step is determine if the relation is a function. So we can do both of these tests. So first, I'm going to check out the x values. So my x values, -2, -1, 0, 1, and 2. Do any of those repeat? Nope. So I'm going to say yes, function, because no x values repeat. Okay, we could also look at the graph, and I could draw vertical lines anywhere on this graph, and every single vertical line will only hit one single point. It will never hit 2 points. It would also pass the vertical line test. Okay, so next it says state the domain. So my domain here, because these are just points, it's not continuous. So my domain, I could actually list out all of the points. So my x values would be -2, -1, 0, 1, and 2. Because this is a set of numbers, we put it in set notation, which are your little squiggly brackets. Next is the range. The range are your y values, and once again we have a set of points, so I can just look and write out all of my y values. So we have a 2, we have another 2. I don't have to write it twice, but I'm going to write it twice just because I see it there, and then 0, -2, and 1. All right, so now let's take a look at our next example. So if we see here, we have our graph and we have a relation. We have it looks like a parabola that is drawn. So determine if the relation is a function. So is this a function? Well, we do not have a list of points. So instead, we have to look at the graph. So if I were to draw a vertical line anywhere on this grid, would it ever touch the function more than once? No. So that means this is yes, a function. Now to explain, we have to write the word because. So explain means you have to write a sentence. And here we're going to write it passes vertical line test. Okay, so now it says state the domain. Now the domain are going to be your x values. Now if we look here, we do not have a set of points, so it's not easy to see our domain. So instead we have to look carefully. So our parabola, will it go forever to the left and forever to the right? Well, the answer is yes. There's arrows, so it's going to be going down and it's going to continue to grow in both directions, side to side. So that means our domain is going to be all real values. Or I could write -infinity and then x, and then it goes all the way to +infinity. But remember, it can never be equal to infinity, so there's no lines underneath. Okay, next it says state the range. So once again, for our range, we're going to look at the y values. So if I look here, do my y values go all the way to the top? Do I have arrows pointing upwards? No. So where's my top point? My top point is at 2. So my function's never going to go above 2 But how far down does it go? Well, both of my arrows are going to go down forever, so it goes all the way to negative infinity. So my range is negative infinity is less than y, which is less than or equal to positive 2. And now we have our domain and our range. All right, so that's part 1 of today, our terminology. So part 2 was a little review of our functional notation. So remember, function notation is a special notation used only for functions. So here we have an example, y equals 2x plus 3. We know that this is the equation of a line, and a line is a function because it passes the vertical line test. Now, instead of writing it as y equals, we could replace it and write f of x, g of x, or h of x, okay, in its place. So let's go ahead and practice. So given f of x and g of x, find the following. So for part A, it says find g of negative 3. Now, if we notice, negative 3 is inside of the parentheses. And if you look at your g, here x is inside of the parentheses. So that means wherever we see an x, we're going to replace it with a negative 3. Okay, so that means when I rewrite this, g of negative 3 is going to be equal to, now instead of x, we put a negative 3 there, negative 3 squared, minus 4 times negative 3. Okay, now I can either do this in my head or I can grab my handy dandy calculator and we can substitute it in. So negative 3 parentheses squared, I'll change that to a parenthesis, and then minus 4 parenthesis negative 3. And we get a final answer of 21. So 21 is our final answer. Now if we take a look at part B, it says if f of x equals 9, find the value of x. So do we know what the value of x is? No, because there's still an x inside of the parentheses. That means the whole equation is equal to 9. So I'm going to take my f of x this time. F of x is equal to 9, so this becomes 9 is equal to 3x minus 3. And now we're going to go ahead and solve for x. So I'm going to add 6 to both sides. 15 is equal to 3x, and then I divide by 3, and x is equal to 5. And we have our answer for x. Okay, up next we have part C. Here it says g of x is equal to 0. Find x. So g of x is equal to 0. Do we know the value of x? No, we want to find it. So instead of putting 0 in for the x, we set the whole thing equal to 0 here. So 0 equals x squared minus 4x. Now, because x is squared, how many answers are we going to have? We're going to have 2. If we have 2 answers, we set the whole thing equal to 0, and then we factor and solve. So here it's already equal to 0, so we can go ahead and factor. Now the first type of factoring we always try is GCF, so I'm going to go and factor out an x minus 4. Then we tee it up and we set both parts equal to 0. So x equals 0, x minus 4 equals 0, so we add 4 and we get x is equal to 4. So now we have our 2 solutions. Okay, if we take a look at part D, it says find f of 1/4. Okay, so now the 1/4 is where the x typically goes, so that means wherever we see an x, we're going to type in a 1/4. Okay, so now I'm going to go ahead, I'm going to plug this in. So 3 parentheses, 1 divided by 4, and then minus 6. And we get an answer of negative 5.25. We keep all the decimals. All right, let's go ahead and check out part 3 for today's lesson, which is writing equations of functions. So this school year, we've learned 2 types of functions. We've learned the equations of lines and quadratics. All right, so remember your lines, they can be positive, they can be negative. Your quadratics can also be positive, which means they open up, or negative, which means they open down. To write the equation of a line, we can do that by just looking at it as long as we can tell what the slope and the y-intercept is. So remember your m is your slope and your y-intercept is your b value. Or if we have at least 2 points, we can use the calculator with linear regression. Okay, to write the equation of a quadratic, we know the formula is ax squared plus bx plus c. We can write its equation in two different ways. We can use the roots, or we can use, and here we're going to cross off 2, we need to have at least 3 points, and we can use the quadratic regression in the calculator. So let's go ahead and take a look. So question number 4, if we take a look at the picture right away, we can see that it is a line. So we're going to need the formula y equals mx plus b. So in order to fill this in, we need to find the slope, and we need to find the y in. Okay, now the y-intercept is the much easier one to find. So we're going to go on our y-axis, which is just f of x, and we're going to see where does it cross, and it crosses right here. So this is our y-intercept, which is going to be 5. Now we're going to look for the slope. So you always start with the point that's on the left. So I'm going to start with my y-intercept, and we're always going to go to the right. So remember, slope is rise over run. So in this case, instead of going up, we're going to go down 1, 2. So that's -2. And then we're going to go over 1, 2, 3. So our slope is -2/3. So now I can write that out in my equation. Y equals -2/3 x plus 5. Okay, so that's how we can write it using the graph. Let's remind ourselves how to do it using linear regression. So for linear regression, you need to have at least 2 points. I'm going to go ahead and use all 3. So we're going to write them in a table of values. So 0, 5, 3, 3, and 6, 1. Now, in our calculators, okay, we are going to go to Stat. We're going to go to Edit, which is choice number 1. And now we have to put these values in our list. So to clear out the list, you go up, you highlight the name, you hit clear and down arrow. Go over, highlight the name, hit clear and down arrow, and then we put in our values. 0, enter 3, enter 6, enter. 5, enter 3, enter 1, enter. Okay, then we go Stat. I'm going to go over to Calculate this time. And then this is a line, so we're going to go choice 4, which is linear regression, and then we hit enter. And then I go down to calculate. Okay, and I can see I get y is equal to -0.66666 all the way across my screen, and then my b is going to be 5. So I'm going to take that decimal and I'm going to change it back into a fraction. So I'm going to remember though that my y-intercept is 5. So -0.6, and I go all the way across my screen. Then I hit math, fraction, and we get -2/3. So -2/3 x, and my b value was 5, and that's exactly what we got up above. All right, let's take a look at the next one. So for question 5, this time we see that our figure is a parabola. It's a quadratic equation. So in order to find its equation, we're going to use a table of values. I need to find at least 3 perfect points. So I'm going to pick the roots and the vertex. So -1, 0, 1, 2, and then 3, 0. And now I'm going to use my calculator to find its equation. So in the calculator, okay, so I've already gone and put these values into my calculator. So now I'm going to go over to Stat, Calculate, and this time I'm going to go down to choice 5, which is quadratic regression. Go down to Calculate, and we've got our solution. So we're going to end up with the equation, all right, -0.5 x squared plus x plus 1.5. All right, let's take a look at the last question, number 6. So I've already taken a look at this table because we don't know what type of function it is. So the first thing we have to do is determine, is it linear or quadratic? So the x's are all changing by a constant interval of 1, but if I look at my y values, we go 3, 1, and then we go back up to -1, which means this is going to be a quadratic equation. So we're going to have to use our quadratic regression. All right, I've already put this into the calculator. So I'm going to hit Stat, Calculate, go down to choice 5, and now I've got my equation. I'm going to write that down. Okay, what I'd like you to do next is I'd like you to flip to the next page, and I'd like you to go ahead and do video 0 worksheet. This is going to be due at the beginning of class tomorrow. Have a great night, everyone.